Hello everyone, welcome to our second video. Today we're going to do vector additions and pick up from where we left on video 1. So let's begin. So we are doing vector. Let me change that to a little bit stronger color. There we go. So we're doing vector addition. Now, in order to do vector addition, so as we saw in the video number 1, say we have a vector here at an angle of 50 degrees, magnitude 5. I'm going to say it's a unitless vector. So as we had discussed in video 1, we can actually break this into its components. Now, this will be known as the y component and as the x component. And in order to find the x and the y, we do y. This is angle theta, which we know, which is 50 degrees. Just going to pull it over. So y is actually equal to 5 sine of 50. And if you don't know how these numbers came, I would suggest you go back to video 1 and focus on the last minute or so of the video. That's where I explain very quickly. And x will be 5 cosine of 50 degrees. Okay, so these are the components of the vectors. Now, in order to add vectors, let's say we're given two vectors over the x and y. So let's say vector number 1, it's the one we just worked up here, 5 at an angle of 50 degrees. And then vector 2, let me change colors very quickly. Let's do spring apparently. So now, vector number 2, if I can just get it to show up. There we go. There we go. Some technical difficulties, I apologize. Now, let's say vector number 2 is coming at an angle of 25 degrees with a magnitude of 10. And you're told to add them. Now, you may be wondering, how do I add this? And they're just given to me on the same plane, so do they even add? So the way you can think about vectors is if you're given money. Don't think about the angles right now for a second. Just ignore the angles very quickly and just imagine the numbers. 5 and 10. Let me switch back to black. If you're given $5 if somebody gives you $5 and then they give you again $10, you will actually end up having $15 this time. So the way it works is just like if somebody was to give you money, $5, $10, it adds up to 15. Likewise for the vectors, in this case, they end up adding. So you have to add the vector components.
You have tinfoil, right?
So you have to add the vector components. The x components and the y components. So in order to do that, first you have to break down each vector individually into its components. So vector number 1 has already been broken down for you right over here, and now let's go ahead and break down vector number 2. Again, let's choose this green. Now, in order to break down vector number 2, y ends up being 10 sine of 25, and the x ends up being 5 cosine of 25. And if you're wondering how, again, remember vectors can just be treated as triangles, so zooming out of the picture, this right here is 25 degrees, and the hypotenuse is 10. So doing a little bit of trick, this is the y, this is the x. So all you have to do, again, if you're not able to recall how to get to y and x, just go back to the previous video and focus there. And if you guys need further explanation, just let me know. I'll make some videos about explaining the trigonometry behind it a little bit more deeply. So moving on with adding the vectors. Let's move back to x and y components. So let's add up the x components first. So in order to add up the x components, you have to add up x1 plus x2. So this right here was our x2, this right here, x1, y1, y2. And this will give you your total components. So now here, our first x1 was 5 cosine 50. x2 is, I apologize, this should be a 10. So here, this will end up being a 10 cosine 25 degrees. Now that gives you your x total, which, plugging into the calculators, now always make sure your calculator is in degrees, otherwise you end up getting a complete different answers if you plug it in as radians. So 5 cosine 50 gives me 3.214 plus 10 cosine 25 gives me 9.06. I'm just rounding up. 6.3. Now if you add them, that gives you 12.277, which I'm going to leave. That's your new coordinate, or your new x component of the total vector. And now the y component, likewise, you're going to do y1 plus y2, and that in our case is 5 sine 50 plus 10 sine 25. I'm just getting, again, y2, y1, plugging it in, and I'm just going to add it straight across. So 5 sine 50 plus 10 sine 25, that gives you a total of 8.056. And our units are unitless because that's what we chose to do in the first vectors. But if you would have chosen to do meters per second, newtons, meters per second squared, that would be the units for your components, again, because remember, the units carry on from your magnitude to your components. So now what that looks like in the graph, we're going to do something called the head-to-tail method. So like its name says it, you're going to grab the head of the vector and you're going to connect it, I apologize, you're going to grab the tail of the vector and you're going to connect it to the head of your vector. So for example, vector number 1 was 5 at 50 degree angle, and vector number 2 was 10 at 25-degree angle. So now notice what I did there. I just picked up this vector and just moved it to the head of it. That's what's called the head to tail method. So now every time that you do this, you can imagine there's a new xy. So that 25 degrees is from a new xy axis there. That will make it simpler and make you see exactly what's going on, why we had to break it down into its components and add it up. So then the total new vector, which I'm going to do in blue, should be the addition of both of them. So your new vector will be from here to right over here. That would be your new vector. And what we found, the total x component and the total y component of the new vector, it's just its coordinates to the final point. So we broke it down into a triangle, and you found the y and you found the x. Now what you have to do is put it back and give it to them in a vector form. So that means you need to find the magnitude, which again, magnitude is just the hypotenuse of the triangle. And we need to give them the direction, because that is what a vector is, or angle in this case. It's a magnitude and direction, remember? So now, in order to give them the hypotenuse of our new vector, all we have to do is the Pythagorean theorem. So we know that the hypotenuse is equal to the square root of x total plus y total. That's what I'm deciding to call this, x total and y total. And this just comes from c squared equals to a squared plus b squared. And then we can call this side A, we can call this side B, and then C would be right there. Apologize for the square. This is A, B, C. Then to find C, you just take the square root. And that is what we have here. Hypotenuse, or C, which are the same thing, equals to the square root of A squared, which is y, plus b squared, which is x. Doesn't really matter the order. I could have switched sides. They're interchangeably, as we recall. B can be A and A can be B. So now, moving on to find that, now we're going to say the hypotenuse is going to be equal to the square root of 12.277 squared. Notice that if it was a negative, the negative squared will end up being a positive, plus 8.056 squared. And this gives you, let's put it in your calculator, which I'm about to do. Gives you a hypotenuse of 14.68. Again, whatever units you will have, newtons, meters per second squared, whatever unit it may be. I chose to do it unitless, so it would be easier. So now that's your hypotenuse. So now we have to give them the angle. So again, from trigonometry, tangent of theta is usually the opposite over the adjacent, which in this case specifically for this angle right here ends up being y over x. So in order to find the angle, you just have to do the inverse tangent, which most calculators have it to as tangent to the -1 of y, which in our case is y total, of course, because that's the vector, x total as well. So y total is 8.056 and our x total is 12.277. So your angle ends up being tangent of 8.056 divided by 12.277. Your angle is 33.3. Just round it up to 3 sig figs. So we added both vectors 1 and 2. So 1, remember, was 5 at an angle of 50, and we broke it down into its components. And vector 2 was 10 at an angle of 25. We broke it down into its components, and then we added the components together to find the new component of our total vector. And graphically, in order to find that, you do the head to tail method, which you just connect, as the name says, you connect the head to the tail of it. So you connect the head of the first vector to the tail of the second vector. So first vector was 5, second vector was 10. So the black and the green form the blue, which was our new vector. And now we found x total and y total, which were here. And then we found the hypotenuse by using the square root of x total plus y total, and it gave us 14.68. Remember the units, in this case it's unitless. And then in order to find the angle of your new vector, you just do the arctangent of the opposite over adjacent, which in this case specifically was y total over x total, and it gave us 33.3. So that's it for this video. In our next video, I'll be showing you guys how to add 3 vectors, which is just the same process. So it will just be a little bit longer and it'll take a little bit more time. It's more tedious, but it's the same process. So good luck in your studies, and let me know if you guys want me to address any specific problem. Email us, follow us on Facebook, and subscribe on YouTube.